All right, so today we're going to look at some of the preliminary things we're going to need when we go on to look at trigonometry. First thing we need is to learn about the circle, all of its characteristics, how to measure angles on a circle and angles in a triangle. So we're going to start with this number that many people have heard of, pi. It's often written pi. And the definition of pi is that if I take the circumference of the circle, which is the distance around, divided by its diameter, which is the line that goes through the center, okay, that will be pi no matter what. It does not matter if you take a big circle or a small circle. The circumference divided by the diameter is always exactly the same. Now we'll do a little bit of algebra here. We get a formula for circumference. Circumference is pi times the diameter. A diameter is also 2 radii, so if you would like, we can write the circumference is 2 pi r. Okay. Now, one of the things we're going to need to look at is measuring these angles in many, many different ways. And one of the units that we'll use are called radians. Now, angle measure of a radian, if I take a unit circle and I rotate through an angle, I'll call it theta for now, in such a way that the arc length here is exactly the same length as the radius. That is the definition of 1 radian. Okay. So we will often use for arc length, let me draw another one up here. If I rotate through some angle alpha, we'll call that arc length S. Okay. And one of the properties of circles is that if I look at the ratio of circumference to some arc length, that's going to be in proportion to the angle that we move through. Okay? So let's do this. Let's say 1 revolution is going to be all the way around, and I'm going to take 1 radian divided by 1 revolution. Okay. That's going to be the same as the length 1 is to our circumference, which is 2 pi times 1. All right, so if we look at this, we'll multiply up by both sides on 2 pi. Okay? So we end up that 2 pi radians is the same as 1 revolution. Okay? So this says if I go all the way around and I want to measure this in radians, that is going to be 2 pi radians, regardless of the size of our circle. Okay. Now we can get one more formula. If I just talk about rotating through some angle, again, the arc length is to circumference as the angle is to going all the way around, 2 pi radians. A little bit of algebra, okay, multiplying up by the circumference, dividing by 2 pi. We find out that the 2 pi's will divide out. Okay? And the arc length is the angle that you rotate times the radius of the circle. Okay? So those are 2 nice formulas that we have. Okay? So we just have to remember in radians, 1 revolution is the same as 2 pi radians. And I'll go ahead and write this down here. 1 revolution is 2 pi radians. Now, technically, radians have no units. So anytime you see values with no units on them, you just have to remind yourself that that is the radian measure. Okay? Now, there's another way to measure angles. And this is one that you may be more familiar with. And this says if I take 1 revolution around a circle, we have units of degrees. So our next units, 1 revolution is the same as 360 degrees. Now 360 is a nice number because it divides nicely. It's divisible by 2, 3, 4, 5, 6, not 7, divisible by 8, 9, and 10. So it's nice to divide everything up. Okay? Now if we take our degrees and our radians for 1 revolution, we see that 2 pi radians is the same as 360 degrees. So pi radians is 180 degrees. This is your conversion factor, just like we converted meters to kilometers, feet to yards, ounces to gallons. We're going to use this as our conversion factor. Okay? Now, in degrees, we can even go smaller and smaller. Okay? So with degrees, we also have minutes. And minutes are subunits for degrees. So 1 degree is the same as 60 minutes. Okay? And we can even go further down to seconds. And this is not telling time, minutes, and seconds, but actually measuring angles. So 1 minute, and we use a tick mark there to give us minutes. That is 60 seconds. Okay? And we'll use a double tick here. So now you should be able to go and do your homework converting from radians to degrees, degrees to minutes and seconds, and vice versa. Let's do one example doing degrees to minutes. Now this happens when you're given a fraction of a degree and you want to convert it to degrees and minutes. Now some of your homework, they're going to ask you to round off to decimal places. So make sure you're very careful looking at the instructions and what they're actually asking for. Okay? So if I have 32.25 degrees, and we want to write that in terms of degrees and minutes, this is really 32 degrees plus 0.25 degrees. You're going to use your conversion to get rid of 1 degree per 60 minutes. Grab your calculator or do the fraction, and 0.25 times 16 is 15 minutes. So you end up with 32.25 degrees is 32 degrees, 15 minutes. With all of these, you want to pull up the whole number for your degrees and then take your conversion of your decimal times your 60 to get the number of minutes. Okay? And again, be very careful, read the instructions. If it tells you to round, you need to round off there. Okay? All right, give those a try. We'll come back and look at some of the other formulas in this section.